Okay, hi everyone. So this is Mr. Ang, and we are going to do an intro video to connecting circuits. Okay, so we're going to go through the parts of the different components first. So if you see here, these are your connecting wires. This one is a switch. You can identify it by seeing the lever. Your batteries are inside your housing. This is your bulb. This is your fixed resistor. There are two meters here. The one with the A is your ammeter. The one with the V is your voltmeter. Okay, I'm going to shift this away. I'm going to go through one by one. So when you want to connect, you will use this thing called the connecting wire, and the connecting wire has two crocodile clips at the side. It is important to note, as a general principle, to remember that metals are the ones that conduct electricity. The plastic does not conduct electricity. Okay, or it's a poor conductor. So whenever you try to clip and connect, make sure that the metal parts are touching each other and form a secure contact. So we're going to look at the battery first. So this is your 1.5 volt battery. So it can be detached depending on how many you want to use. Just make sure you put it in and make sure it's connected securely. To connect the wire, you can put it at the side here if you want, but this is not recommended because this is very loose. So a better place to put it would be here at the side. However, when you put it at the side here, please take note that this part here is actually plastic, so it's not exactly the best, gives you the most contact. So the most secure contact is actually to pull out this tab here and put it in. So you can see that the whole crocodile clip is clipping onto the whole metal tab here. So this is, we recommend this is the most secure way. Okay, the next place you want to clip is clipping it below. Okay, you want to make sure you clip it at the right place because you want to make sure that the current flows through both the batteries. You wouldn't want to clip it here because in this case you only flow through one battery, right? Okay, so I'm going to put it back. I'm going to put it aside. Now the next thing I want to go through is this thing called the switch. Okay, the switch itself is identified using the lever. You will see that there has two wires already joined to it. So if these two wires are missing or have dropped out, please inform your teacher because you need these two for the switch to work. Okay, so one of it you can connect it to your circuit any place to it, so you don't need to use an additional connecting wire. The other part you can connect it to the next component that you want. Okay, here at this point, sometimes this plastic insulator may drop out. It is okay, don't worry too much. Just be mindful that when you clip on it, make sure that the circuit is switched off, or in other words, that the circuit is open before you actually do handle all the circuits. Alright, just in case that you get a little electric shock from it. Okay, so now I've done it, I want to show you how do you know whether it's an open or closed circuit. As you can see, the red wire comes in here. This carries the current, and then here there's a little gap here. This gap creates an open circuit. So if the lever is being pushed down, it provides a closed path for the current to flow through to the other side. However, if I pull up the lever, this creates an open circuit because there is now a gap. Alright, so this is to remind you, this is when the switch is open, this is when the switch is closed. So let's keep it open until when we need to close the circuit or when we are done. The next thing I want to introduce is the light bulb. So you can see the light bulb is already housed in nicely. The bulb itself has these two knobs. Sometimes the knobs are already unscrewed for you, sometimes it is not. It is most advisable to unscrew the knob to its maximum and then use your connecting wire to clip it below. Clipping it below gives you the most secure connection that you want. Okay, so I'm going to do it here. And let's adjust this. And the next thing I want to talk about is your meters. Now this is very crucial to take note of. So this is an ammeter. As you can see here, there's a plus and a minus. You can recognize it by the red and black, or you can just look at the signs. Now it's important to connect the ammeter in the right direction because if you connect it wrongly, the meter will not go to the right positive, but you'll go to the left. I'll show you what I mean. Okay, so suppose my ammeter is here, and I'm going to put so this function as the same as the bulb. I need to unscrew and make sure I clip it below. Okay, and you unscrew and keep it below. Okay, and then my other side of my battery is here. I'm going to clip it here as well. So once I have done it, you will see that actually I have already formed kind of like a closed circuit. So if I close my switch, actually my meter moves to the right and my bulb lights up. This is showing me that the circuit is working. Now what happens if I connect it the wrong direction? Okay, suppose that now I flip it around and I connect it the wrong way. How do I know that it's the wrong way? What will happen? See, I look at the meter now. If I connect it wrongly, okay, you realize that the meter went to the left. Now this is not what we want, and this is not good for the ammeter because it will spoil it. So whenever you see the meter move to the left, it means that it's connected wrongly. So how do you tell whether it's connected? What's the correct way of connecting? Basically, you just need to look at the negative sign. The negative should follow the wire to the negative of the battery. So it should be the closest. So I say again, the negative side of the ammeter should follow the wire to the negative side of the battery. Okay, so let's put it back in. Now the last thing I want to talk about is the voltmeter. But before that, let's talk about the fixed resistor. So in case your experiment doesn't have a light bulb and you need to use a fixed resistor, it works similarly. Okay, you just need to connect it at the side here, clip it at these two rods that you can clip on, and it will still work the same way. Of course, it doesn't light up, but it provides the resistance that you need, and you can also take a reading from it. Alright, so this shows you that the circuit is complete, the current is flowing. When I open the circuit, the meter goes back to 0. Now I'm going to just stick using this, and I'm going to move on to this thing called the voltmeter now. Now if you realize the ammeter has been connected in series, the voltmeter needs another loop by itself because it needs to be connected in parallel. So how I will do it easily is to always start with the voltmeter separate from the rest. So make sure I connect the rest first, then I'll add in the voltmeter. And when I add in the voltmeter, I provide it 2 wires first, so that I have these 2 clips ready and I can just join in anytime I want. So in this case, I want this voltmeter here to be parallel with this fixed resistor. So all I need to do is just to add on to the space given here. So it provides a second loop. Around the fixed resistor. So now if I've connected correctly, okay, close the switch, you'll see that my voltmeter has a positive reading, my ammeter has a positive reading. So does the voltmeter have a direction as well? Yes, it does. So you can see here, this is the negative. The negative will flow to the negative and closest to where my battery's negative is. The positive should be closest to where my positive part of the battery is. Okay? So if I'm unsure, you can always go to see your teacher's setup in front to have a better understanding. Okay, so this concludes the introduction to connecting circuits.